crooked today. That's a good way to start it out. All right, well, let's just start. I'm going to do the whole intro thing and all that, even though there's not really anybody out there, because we need it for the...
Hi, nobody? Well, there will be later.
Nobody out there. All right.
Have a little echo.
Yeah, there's a little echo. Hopefully, I think it may be mainly on my end. All right, welcome back to another Corona Geek here, where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever, and today we're hanging out, but we're not hanging out on the Hangout. Google's having some difficulties, which is, just another sign that you are not too big to fail. So we're here on Google, or GoToMeeting rather, and it's pretty cool. We got the HD faces going on here. We're gonna check out some code as we go. Hey, there's Matthew joining us in all his Technicolor brilliance. Oh, he's wearing green.
No intern.
He's wearing green. Happy St. Patrick's Day to everybody who was out there who celebrates that sort of thing.
Oh, is it?
All right. Well,
I got a small piece of green here.
A small piece of green. Well, fortunately, there's no virtual pinching on this this episode.
Yeah. I know Matt's clicking around for it right now. He's looking for it.
I'm clicking you right on the face. That's what I'm doing right now. You were crooked earlier.
Yeah, see, I told you. I felt crooked.
You should have had a V8.
There's so many places you can go with that.
So today's topic is going to be about physics API, and then we're going to go look at what Sergey has been doing with porting his Kubicorn app to HTML5. It's almost too much for
Corona.
Too much for me to say. I'm like, it's just a lot to unpack. But hopefully we'll go through all that, and Sergey will shed some light on it. So Ed is going to cover the physics API, and as we go along, as always, if you guys have some comments or questions or whatnot, let's have a good discussion about it. So let me change over and make Ed the presenter. Are you ready to show your screen, Ed?
I'm ready to, I've got nothing scary on my screen.
Are you ready to receive permission?
I think I'm in charge. Let me get rid of this thing. Yeah, the bad thing about this is I can't see what you're seeing, so I have no idea. If you guys should be able to see my screen now.
I still see you. Okay, now there's your screen. Let me resize
I'm
this a
looking
bit.
over at it. This is a little bit bizarre from my usual experience with Google Hangouts. All right, so last week or the week before, I can't even recall.
Last week.
Must have been. Yeah, we were talking about forces, and we just started talking about it as a result of some the other horizontal. Yeah, I'm really on top of it today. The endless runner. That's right. And the question arose: when should I use one type of force versus an impulse, and things like that. So I said, in my usual bright manner, "Hey, that'd be a great idea for the next show." Volunteering myself, of course, to talk about it. So what I did was I put together a little example showing the application of some different forces and impulses and what you would expect to see in Corona. So this, before I get started, the code that goes with everything I'm going to show today is available out on GitHub, and it's already out there. I don't know why I'm saying this, because nobody's watching us live. But if you were watching us live, you could in fact be following along and looking at the code. Now, I know that some of you guys probably have the code already. In either case, what I did with this was be warned in advance that the code that you find in most of the files is going to be kind of advanced if you're a new Lua programmer. I'm not saying it's like genius stuff, but I used shortcuts and tricks to make my life easier when I did the demo. So, if you look in the main file, what you're going to see is just a few lines of code. Is this too small to see?
It's small, but I think we can see it. If you can bump it up, that'd be cool.
Let me make that a little bigger. Yeah, I always forget to do that before we start. So there's not much to it. The first two lines of actual code is just me doing some initialization stuff to make sure that the output comes out to the console right away. Getting rid of the status bar that shows up at the top of the device if you actually run it on your device, or the bottom depending on your device type. The next 3 lines are, just think of that as magic code. That's me including my a small portion of the Super Starter Kit, basically the globals, some extensions to the tables and I/O and some other of the standard Lua classes and Corona classes, or yeah, I'll call them classes. And then the last line is including my collision calculator, because I'm a super lazy guy, happy to be lazy, in the sense that I don't like to do anything more than once, or like do a complicated piece of code more than once. So the traditional way to set up collisions is to figure out how many objects you have and assign a number to them and do some addition and multiplication depending on how you approach. In Corona, not Corona, in Lua 5.2, I believe, which is the one that is attached to Corona, we don't have the ability to do bitmap manipulations, so bits. We can't do bitwise ands and ors and stuff. But the physics engine that we're using uses bits to determine which objects will collide with others. It uses bit masks. I'm probably already talking above the heads of some of the folks who might be listening later. Long story short, there's different ways around it. You can do addition and multiplication to avoid those kinds of calculations and come up with the correct numbers. So people will traditionally create a graph of objects in their games versus objects that collide with each other, and they'll do the math and they'll create these numbers, and then later on when they create their physics bodies, let me find the code here, they will add a physics body, and they'll add it to some object. They'll decide what type of physics body, be it static, kinematic, or dynamic. They'll give it some parameters like density, friction, bounce, and they will also give it a parameter which is the filter. And the filter is this magic number or set of numbers which tells the physics engine this object will collide with this object, but it won't collide with a different kind of object with a different filter number or set of numbers. So what I do is my collision calculator is, instead of using math, I create an instance of it by calling new calculator, and then I just give names to the different object types. So in my demo, I have the pads, which, if we look at the demo, these little dealy bob, the colored squares at the bottom are the pads. I have ships and little yin-yang symbols, so they're both going to have the same marker type, so I just sort of made up a weird word, ship-yang. And then I have markers. So this is the ship, this is the yin-yang, and then the little red circles are the markers. And in my example, only the ships and the yin-yang symbols will collide with the pads. So the next statement is collides with, and then I say that ship-yang collides with pad. It does the math and the behind the scenes, and then later on when I want to create the object, instead of putting a number in filter, I just make a call and say, give me back the right numbers for the pad, or give me back the right numbers for ship-yang, and it does that for me.
That's a lot more intuitive.
So Mr. Lazy. Yeah, I prefer to use. I like it because it's really short. You just give names. You can have up to 16, which is a limitation of what's the physics
Box
engine?
2D.
I always forget this. Box 2D. Box 2D can handle up to 16 different unique types of objects. So the bit mask can be 16 bits wide. And then in this case, you simply tell, what this is saying is if I wanted to change this and have like another object, like a bullet, let's say, and I wanted the ship to collide with the pad and the bullets, I could just do this. And what that will do is it'll create a fourth type, which is a bullet, and then it will say ship-yang collides with pads and bullets, and in the background it does the calculations, the inverse calculation. It says, well, okay, well, if I'm figuring that out, then I have to figure out the mask for pads, because pads collide with ships, so that's a different number. Anyways, this makes sense to people who've done it themselves. You've got to do both sides of the calculation, but being lazy, I figure, why don't I just have the computer do it all for me? let's undo that so I don't break my example. All right, so the only other thing in main.lua is, let's see, the physics. I set up physics, and I just give it sort of a traditional gravity value. Instead of 9.8 meters per second, which is what everybody thinks, and I just put in 10. I could make that anything. But for this example, I wanted a nice round value. I have the statement in here, if you're running this later, to enable the hybrid mode. So if I disable that, or that is, I enable it by uncommenting it, and I reload, then you'll be able to see the physics bodies. And if you look carefully, it's probably a little bit hard to see on the screen here, but you should see some green lines here, which is showing you where the objects are mounted relative to the center of the object that they're mounted to. For example, this is probably really hard to see, but the yin-yang symbols here are attached to the pads for the purposes of my example via a pivot joint. And the pivot joint is connected from here to the center of the pad. So there's a little line right there. Yeah, let's turn that off. I know this seems like a long description, but I just wanted to get through this once, and then you'll see that the examples themselves are fairly straightforward. The other big piece of code, and I am not going to go over all this because this is the part where I used a lot of tricks, is basically at the top of the forces and impulses file, you'll see a section in here where I require builders, which returns a module called builders. And then builders has in it a function to create the pads, another one to create the ship, and another one to create the yin-yang symbol. And these are, I strongly suggest that once you've played around with the examples that you go through here and kind of look at what I did, because this would probably be useful as far as folks who are just coming up to speed with Lua and want to learn some interesting things. Like here I used, in create ship, you can pass it a number of parameters that tell it where to place the markers. So if we look back at the example, let me reload that, you'll see that the first ship here has one red marker, and the next ship has two markers. So the way I did that was I passed in a list or a table that said put a marker at this offset relative to another marker here, and later on I reference those markers and say where are you relative to the position of the ship. I'm going to apply a force at that point. So they're like the visual shortcut for the example, and it's a shortcut for me when I'm doing my coding. Now I wouldn't actually suggest having physical entities, but I did that in this case because I wanted something that would follow the ships when they were moving, so you could actually see the markers moving along with the ship. All right, so enough of the code. Again, I suggest folks that play with the examples and then dig into it later and say, oh, well, that might be useful to me, and I don't know why you did it that way, and I think that's terrible. Because Sergey will have a better way to do it. He always has a better way to do it than me. No, not always, but a different way.
No, you have a good way. It's a good way. Okay.
All right. Well, thank you. So the core files here are, there's two files. When you run this example, there is forces.lua and impulses.lua. And if you want to run the impulses example, you simply comment out line 19 and you uncomment line 20 in main Lua. And you reload it, and it will load the impulses example. So this is the cheater level loading method for doing a demonstration. All right, let's speed this up a little bit. So last week we had some questions with regards to what will a force do versus an impulse, and when is it appropriate to use one over the other. And what I decided to do is just sort of give you a smattering of different examples of forces in action and what you could expect to see. So in the first forces example, what you've got is I'm going to apply a force, and upward in the game is always negative in the y. So negative y is up, just for folks who are new to how things are laid out, because down are the direction that the system works in is down is positive y, and to the right is positive x, which is a little bit different from what is the traditional axis system that we all learn in school. It's
Cartesian.
Cartesian, yes. Cartesian y is positive, but in graphics, usually y positive
This is our Jeopardy show
moving
today.
downward.
What is Cartesian?
Yes, yeah, yeah. I should make a little, a little music there to go with my questions. So, the proper way to apply a force, if you want to move an object, is people always trip over this. What they think is, oh, set. Let's see, what's the actual function call? It is apply force. They think, oh, apply force. So I call it one time, and they expect their physics body to just start moving and stay moving, which is wrong. Apply force is something that you have to apply continuously to keep the physics body moving. And when I say continuously, the typical application is every frame or every set period of time if you choose to approach it differently. So what I've done here in my example is when I click on the pink box, a force is going to be applied to the center of the ship where the marker is in the upward direction, and the magnitude of that force is 100. Now if I click and let go, it's applied for a little bit, and then the ship just drops back. So what that gives us is this force is applied, and it starts to accelerate the ship, and the longer I hold it, the faster the ship goes based on settings. And in my case, there's no drag or other attributes, so this ship, if I were to hold down the pink button, would just accelerate continuously, although of course it would be off the screen by the time we could see it really moving. But you can see even if I just hold it down for a little bit, but then if I really hold it down, you can see it sort of zips off the screen. So the next question that people run into is, what if I want to apply multiple forces to the same body? What's going to happen? The physics system in Corona is additive in the sense that if I apply multiple forces at any particular time, let's say on a frame, those forces will be added up by the physics engine, and then the cumulative force will be calculated against the body to figure out what happens. So in my next example on the green button or the green pad, I've got two forces which will be applied on these red dots, or where the red dots are. They'll be applied against the ship body. Again, they're upward, and each of these is a magnitude 50. So the total cumulative force will be 100, and it should behave, because they are balanced along the horizontal axis, and they're balanced in force, it should behave exactly the same way as the single point in the center did. As you can see, it does exactly that.
So this is the same apply force, just split between the two halves of the object. Okay.
Yeah, it's a little bit different in that if the ship started to tilt for some reason, or it was tilted at all, it would not behave the same. But as long as the ship stays on the same vertical axis, everything is, it's shorthanded to being as if it were 100 in the center. So that's what the next thing is going to demonstrate. So people get past this stage and they say, okay, I've got single forces, I got two additive forces, now I want to make a ship that thrusts and flies all over the screen, and the forces are doing the right thing, and it's like a rocket's coming out of the bottom, or whatever, something like that. Let me bring this down. So in this example, it's the same as the previous one, except the left thrust is a little weaker, and then the forces are both reduced just to make the example easier to see. So what's going to happen is, as soon as this thing starts to lift off, it's going to tilt to the left. But this is where people's thought process breaks down. They're not grokking the whole thing about how physics are applied, and they're kind of expecting the ship to veer off to the left, but then sort of arc and just keep going. But that's not what happens. Instead, you do this and you get this twisty little, oh, perfect landing. Yes. You get this little thing. It's like, why did the ship go into this weird spin? And the problem is, I will upload this. I didn't upload this in the original GitHub upload. I'll put it up there a little bit later after the show. what we've got is unaligned forces. Oh, let's show the right one. Okay, it's not going to let me zoom in. Okay, there. So what we've got is unaligned forces. And when I say unaligned, is these pink lines are the two forces. The force on the left is weaker, the force on the right is stronger. But as time progresses, these forces initially start off aligned with the axis of the ship, but they're pulling on the body at these points. And as time progresses, the forces keep pointing in the same direction, but the ship is pointing off to the left, which is obviously no good. And if you think about it, this is going to give us that weird spinning effect. So what we would prefer to do is create a scenario. No, now it doesn't want to change. Create a scenario instead where, regardless of the angle of the ship, the forces are always in line with the ship's axis along its vertical axis. So I won't go into the math of it other than to speak to it. You can look at the example that I've given, and it uses my toolkit. It uses the Math 2D toolkit that comes with the Super Starter Kit. But the basic calculation is, if you want to keep forces in line with the body, is you calculate the angle, the rotation of the body, then you convert that rotation into a vector, and then you normalize that vector, which is to mean, for people who are familiar with 2D math, that means make the vector the length of 1. Whatever the rotation is, however that comes out, it's a unit length vector. So if you were to calculate the length, it would be 1. And we do that because the next step is we then scale the vector by the quantity, the magnitude of the force that we want. So if we want a force of, let's say, 50, we would scale our vector by 50. And at the end of the day, what we come up with is a vector that has an x component, a y component, and we take those and we plug them directly into the set, the applyForce. So I guess I could show you the code so it's a little more clear. Let's see, that was example 5.
And you say all of this is already kind of pre-calculated for you with the SSK Math 2D library.
Right. Yeah, I mean, doing it by hand is kind of long because you have the sines and cosines, and with the non-Cartesian system, you have to rotate everything by 90 degrees. You have to kind of know what's going on, because this is not the same. This is another problem that folks who are new to graphics programming encounter, is that they come from working in a Cartesian system. So they got done with their schooling, and they learned how to do this in the Cartesian system, and then they get to the graphics system, everything's sort of rotated by 90 degrees. But it's not obvious. You do it, and you're like, why does my calculation come out, and then my thing's moving to the right, or it's doing something wonky? It's like kind of what I wanted, but it's off. And so, anyways, in SSK, it's all...
I have a note. When you're dealing with physics and rotations, make sure that zero rotation of your files, like if you have a ship, draw it not like pointing to the up, but pointing to the right. If it's pointing to the right, it is everything will be aligned with your image and with the physics engine.
Right, right. You're right. So may I reiterate? Basically, what I said previously is that the rotations are as if it were a Cartesian system rotated to the right by 90 degrees. So, but then everybody, even me, we make our graphics images, we're doing all the work, and of course we make our graphics image with the ship pointing upward. Can you see my fingers? So let me, we make our graphics images like this. But what he's saying, and this is the right thing, if you don't want to have to deal with a Cartesian offset, do your artwork with the graphics pointed to the right, and then apply your forces, and everything will be right. It'll automatically look like this when you're doing the work. So it's one of those things you have to experiment with, and then suddenly you're going to have an aha moment. But if you're lazy like me and you like to keep everything in your normal up-down orientation, you can just use SSK, and I take care of that for you. So for me, rotation 0 is up instead of rotation 90 is up. So again, let's see. What we do here is, okay, so I get the rotation of the ship. I convert that from an angle to a vector, and my tool automatically returns that as a normalized vector, stores it in force 1. I then scale that by 25 and 35, 25 and 30, and I have 2 different vectors. And then I take the components out of those and apply them to the ship. So in that case, when we run the same example, so this one here tilted and did this wonky thing. Damn, I'm good today. Oh, that's my one bleep for the show. So this one, on the other hand, is going to arc and fly off to the left in a way that we expect. Of course, it's a little bit hard to see with the laggy camera there. I don't know if you can see that.
That's cool.
That's cool. So, or if we do this, we let it tilt on its side. Now it's tilted on its... Oh, stop. Anyways, you get the idea. Okay, so let me speed this up a little bit. In addition to applyForce, there's another force, which is applyTorque. And a torque is simply a rotation around the center axis. There's no concept of offsets. So with applyForce, you can apply the force on the body any place on that body relative to its center. So 0, 0 would be applied in the center, and 0 plus 10 would be with the center, and then, let me do this right, downward. So these are down, or minus 10 plus 10 would be over here on the left, minus 10, I'm sorry, plus 10, minus 10 would be on the right. Now torque has no such concept. It's just a single value. I'll show you the code if I can find it. So the applyTorque function is simply applyTorque and the value, and this is always going to be a positive value is always rotating left to right, and a negative value will rotate basically counterclockwise. Probably should use terms that folks are used to using. So if I push down the button and hold it, torque is applied and continues to be applied in this example. Again, like said, oh man, I can't remember the names here. Again, like applyForce, torque is applied every frame if you want it to continue modifying the body's angular velocity. Let's see. We did that one. Pivot plus force. Another thing people try to do, so we did this ship example where the forces are aligned. Another thing people try to do is very similar, is they try to have some object that they want to rotate. So these wheels, these yin-yang symbols, are attached to the platforms, which are static. They don't move, via a pivot point. So when I apply a force, it's allowed to rotate around that pivot point, but it won't be moved. So similarly, in this example, what happens if I click this, the force is applied upward relative to the position of this dot, but it never compensates for the rotation of the yin-yang symbol. So what you see is when I hold it, it does this weird thing where eventually it just keeps pulling up on that dot and it stops moving. What you want to do is the same calculation I did for the ships, which is calculate the angle of the yin-yang symbol and then change the force, let's reload that, on this dot so that it's constantly pointing in the right direction and dragging the circle around. Alright, so what's the difference? Last week this was asked. What is the difference between impulses and forces? Forces, as I said earlier, are supposed to be applied every frame or every period of time, usually on a set period of time, so 10 milliseconds apart or however many time periods, and always the same, so you can get a nice consistent acceleration or motion. Impulses, on the other hand, are designed generally to be applied once per period of time and then not applied again until some action occurs. And an impulse basically can be thought of as like getting a kick in the seat of the pants. It's going to apply a lot of force, and you're going to instantaneously accelerate that object away from or in the direction of the applied impulse. So if you recall, in the previous example, we applied a force, a constant force of 100 in the upward direction on the ship. Now when I press this blue square, instead of a force, we're going to get a one-time impulse applied to the ship. And you're going to see that this is much, much stronger in terms of how it is resolved by the physics engine. So a single click and that ship just, it's gone. It took off. That's the other thing that people get mixed up with regards to impulses and forces. Forces applied over time have a lower resulting acceleration than a single impulse of the same magnitude applied once. So in short, you could just think of impulses having a much stronger response than forces. So when you're using impulses in your game, make sure that they're small to start and then ramp up. Otherwise, you're going to do what I always do, which is you apply it and then your thing zips off your screen. And you go, "What? That's not what I wanted. Well, let's make it half as strong. Still too strong. All right, so I start out real small. A medium force is just an example, so people can look at the code and see. But this one, a little bit better. And then a weak force of only 10 barely gets it off the ground. So what happens, we should be able to figure this out by now, if we do an offset impulse. So it's maybe hard to see, but this dot is where the impulse will be applied, and it's slightly to the left of center. And when I do that, I'm going to use the medium force. It's going to be in the upward direction, and my ship flies up and has a happy landing. That was a happy accident, by the way. I was so happy that that came out, I left that value just as it was for the demo. What else? There is also an impulse torque. So it's a little bit different in the sense that whereas if I have a 100 impulse, it's very strong. Where I have a 100 force, it's much weaker. Torque, on the other hand, is applied, it's really hard to describe this. It has something to do with the mass and the moment of inertia. The moment of inertia has to do with the size of the body and the distribution of the mass, which is in this scenario is always considered to be equal. There's no parts of the body that are more dense than the other. But the calculation basically says I don't know where Box 2D calculates the moment of inertia to be. No, that's not right. The moment of inertia is in the center, but I don't know where it calculates the arm to be. In other words, when I apply torque, I don't know if it's applying the force where my cursor is, or out here on the edge, or if it's a distributed. I don't know how they do this calculation. But with a torque of 200, you would expect, I was kind of surprised. I thought, well, impulse is 100, so strong, I figured this thing was going to go zipping around. But even with 200, it hardly rotates the body. It applies that bam, that kick, and
kind of the Ford Fiesta
rotates.
of torque.
Where? Yeah, okay. Ford's going to come after you now. So let's see. I'm sorry. Let me just go back to this. Whereas on the forces, let me reload that example. Here I have a force of 20, much weaker, right? 10 times weaker than the impulse force. And the moment of inertia is going to be the center. And the arm of my torque is going to be, or the place where I apply the torque is on the outside. And if I hold this down, you can see that it gets zipping around. So it's much more effective in terms of rotating the body. So my only lesson there for folks is don't be surprised that angular impulses, or what is it called? Yes, angular impulses are much more weakly applied than linear impulses for whatever reason. I don't know why that is. And then this is just a demonstration of the same problem. So every time I click the cyan or the light blue square here, an impulse is going to be applied up. So it depends on where this dot is. First time I do it, everything looks good. But if I keep clicking it, it's going to have the same problem, that the force is not applied at the direction of the at the proper direction to keep it spinning.
Oh, that's interesting.
And that,
Yeah,
I
that's
think, is
interesting.
it. These pieces of code are very short. If you look through one of these, basically it's the first part of the code. Let me scroll to one of the examples here. First part will be create a ship, position that ship at x35, y280, and this bit right here is saying place a dot. I'll show you the exact example that this is. Place an anchor point at offset x0, y0, which is the center of the ship. And if I wanted to add another one, I could do just simply put a comma after this, copy this piece of code, and let's say x minus 40. And that should put a dot somewhere near the tip or above it. When I reload this, I save. Oh, I'm in the wrong example. Good job. Sorry about that. Okay. Pretend I did waving my hands and undoing all that. Okay, so now when I save it and run the forces example, there it is. It creates another dot. And then later on, I can get that position, and I'll show you how to do that. The next part here is to create the pad. And basically what I did was I took the X and Y position of the ship. This is just me being lazy. And I plugged them in as the X and Y position, and then an offset of 60. I passed in a color, and you could make any color table, like let's just say 1, 0.2, 0.6. The color codes you see, pink, red, and whatever, are globals that I made in my library because I'm too lazy to type these things out. Oh, let's do this. So change that, and the pad color should now be sort of grayish, I think, or well, okay, purplish, whatever. And then I pass in the ship, and the reason I pass in the ship is because it does some magic behind the scenes, so that when I click on the pad, it tells the ship to do something. This is the part you don't need to worry about. Yeah, even this begins to be a little technical. I should probably just let people dig through the code and then ask questions.
Theo, did you have any questions, by the way? I know that you guys had kind of gotten into the discussion last week about the physics API, so there you go. Yeah.
All right. Can you hear me now?
I can hear you.
Okay, sorry, I had to unmute myself. Yes, that does answer the question. I did my own research between last week and this week to answer a few questions I have. I guess in trying to understand the difference between torque and in that last example you used, what was it, impulse, or I forgot.
Well, torque, okay, the two differences are a linear force and a torque, which is going to be a force applied around the center of the axis of the body. Always in it's always going to be in the correct direction, either to the right or to the left, clockwise or counterclockwise.
Right. Okay. So I sort of imagine if I apply to maybe a real-world situation that you have maybe two wheels, and one wheel has a knob that is on the edge of that wheel, and you're turning it around. That to me sort of simulates maybe torque. While the other example is the knob is in the middle of that wheel, or maybe kind of like those submarine doors, you know, where you have to turn it and it's in the middle, and that's maybe a little different. I'm not sure. I'm no physician.
In the physics of it, you're going to get the same. They're both going to result in torque.
Okay.
How much torque is the question? I mean, how much torque you get on a physical body is a result of leverage.
Okay.
Which is, in my examples, I don't know if you can still see my screen, but is the little red dot on the outside of the circle is in a sense showing you where your leverage point, your arm is on the physics body. So just to clarify, a force applied in a straight line, it's hard to show because what you should really see is a line from this dot to the center, and that's your lever. And your lever is going to rotate the body, and it's going to apply torque. So torque is always a rotational force. I don't want to misspeak here. It is always a rotational force. Where yeah. You can get torque as the result of a linear force, but the only reason you'll get torque as a result of a linear force is because linear forces, at the end of the day, can be thought of as forces applied around the center of mass. So if the force is directly through the center of mass, there will be no rotation. But as soon as that force is offset from the center of mass, the body will start to rotate as a result of some of that linear force converting into torque.
Okay.
So, for example, in this yellow example, there's two equal forces that are being pushing up on the bottom, but because one of them is weaker, that can be translated as an off-center single force, and so it gets this weird rotation.
Right.
So when you're creating projectiles, and I don't want to go too long because I want to hear Sergey's example. When you, sorry, I'm going to lose my thing. I've got 8 desktops going on here. Sorry.
Show off.
Yeah. Well, no, it's okay. Whatever. What was I going to say? When you want to make a projectile that can change its direction over time, like a rocket or something like that, it's going to be a linear velocity applied over time in the direction that you want the projectile to go. And that will steer the projectile as you wish it to. And you can play around with when that force is applied and the off-centerness. Like you can lead the force, you can put the force a little higher up or a little further back, and you'll get different responses. And when I say response, what I mean is what the body does as a result of the input. So hopefully that helps.
I think that's an excellent place to transition. If we can get Sergey maybe to...
Yeah,
I think he's putting together a puzzle over there, or maybe knitting something. He's kind of crunched over.
I am making an anasim out of a regular
I knew he was doing something crafty.
Yeah, according to this template.
Well, yeah, no,
literally crafty.
Well, thanks, Ed.
Okay, Sergey.
Scissors and stuff. So
So thanks, Ed, for going through the physics API, putting all that stuff together. We'll definitely put a link in the show notes so people can go download that. I know I'd certainly want to dig through the code examples and see how you've put everything together. You know, just the code bits, not necessarily the physics API and all that kind of stuff. I'm just curious as to how you've
curious about the secret sauce?
Yeah. And a good example of how to implement SSK as well. So we'll put a link to the show notes. So Sergey, I think what we're interested in is you took your Kubicorn game that you created in the what was it, the London? What was they call that? London Dare, Luden Dare? How you pronounce that? The Game Jam.
Yeah.
And you ported this to HTML5, which runs your Corona SDK app. So we're really curious about that. So let me change presenters because we don't want to look at Ed's desktop while you're presenting. Although he has 8 of them that we could look at.
Those are just the ones in front of me.
You have other desktops in other rooms?
No, on my desk. Literal desktops and virtual desktops.
So for anybody who doesn't know, Sergey basically, runs this Corona app in the Chrome browser, and you can play your stuff just like a HTML5 app.
So let me walk you through. I think I can manage it in 15 minutes. So what was I experiencing?
Sergey, your microphone's a little weak.
Yeah, it's not as loud.
I don't know why you got quieter all of a sudden.
Now it's better?
Yeah, yeah.
Okay, so let me find their post. Here is it. So this is their app running in the browser, in their blog post. So what I do, I'm using Chrome web browser, and I'm right-clicking and clicking inspect what's everything inside the page. So I search the page and see, there's something interesting. Oh, there's iframe. So I copy this link. And open it in a new window. And I have their example in the separate window. So I hit inspect elements here as well, and I'm showing network. So and I'm refreshing the page so the network can be shown what's going on. And we can see here. So it does load 3 files: Corona Physics HTML, which is the main one, Corona Physics JS, which is JavaScript, and some data files. As you can see, there are a few blob images that are not going exactly from any direction, but from somewhere from the script, so from JS file. So the whole example consists of 3 files: HTML, JS, and data. So next thing what I do is I open my terminal, make a temporary directory. Then I have this program called wget, which is webget, that allows me to download files intact, not modified by the browser or anything. So I copy link address and write wget this file. And this file is saved to my local directory. And I do the same for the rest of the files.
So at this point, you're just downloading these files using the terminal window. Okay.
That's right. So now we have 3 files: HTML, JS, and data. Let's start up, for example, Sublime. And let's look at HTML. So what we have at the HTML, this is a really small one. And what it does is only, let me find it. Basically, it loads only JavaScript file. Here, at the very bottom, SRC Corona Physics JS. So you only have, if you rename your source files, you have to change this line in this HTML file. That's all. Now let's look at JS. This is a big file, over a megabyte, so it's almost 4 megabytes. I believe it has all the Corona compiled or something like that in JavaScript form. So this is really something. Maybe I'm not really sure how it gets all the code. Maybe it's not entirely contained in the JavaScript, but maybe it's downloading something extra. But I don't think so because Chrome doesn't show it. So maybe it is the entire Corona in JavaScript. And what it does is actually very few things.
Can I ask you a question?
Yes?
I'm sorry. Have you tried running this locally on your desktop with and disabling your network connection?
Not yet. I can try now, but you will fall off.
No, don't do it now, clearly. But that would answer your question as to whether it's reaching out and getting some other secret
Well,
sauce from Corona.
According to the Chrome, it doesn't.
Oh, yeah, you can read it right there.
Yeah, it's only those three files, and these files are coming from the JS, not from anywhere on the network. So I think it does not use anything else. But it just doesn't look like so because there's only so few code and it's so well organized, I guess. Something like that. It doesn't look like something too binary. So at the 118 starts interesting things. This is resources that are contained in data file. So we have how to zoom in Sublime.
Command plus if you're on the Mac.
Oh, great. Thanks.
So
what it does is maps all the files that you have in your Corona project to this data file. And these are offsets, binary offsets. So from 0 to 91, you get config lua. From 91 to 6729, you have create PNG image, and so on for every other file. So now we know what's inside this Corona physics data file. This is all binary. So let's open it in something else.
Sergey, before you go off to that, what you were just looking at, what exactly was that again? Go back. So they get the data request.
This is Corona physics JS.
Like the 0 to 91, pulling the config. I mean, what are do you know what those numbers represent?
Those are offsets. So first file is config lua, and this takes 91 bytes. So first 91 bytes are config lua. Next 6,006 kilobytes are create PNG file. So and next it goes on to the very end of the file. You can see last number is 246 kilobytes. So and the size of Corona physics data is exactly 246 kilobytes. So there is no compression, no extra physics under the hood, just plain data files concatenated one after another. I want to open it with something different. I don't remember what was it exactly. Maybe text edit.
Yeah, I've seen some hex editors.
Yeah.
Text edit. Okay.
Text edit. So as you can see, the first 91 bytes is config lua. So I hope you can see it. It says application, content, width, height, scale, letterbox. After that, you get binary data, and the header is PNG. So this is a file. If you scroll down a little, you can see the source code of the example. So module package C all, well, very bad code style, but who cares? So here's the drag body function, and really all the code which Corona uses in this.
So I guess
sample.
if you so that top part there is like gobbledygook. I mean, would you be able to see better if you opened it up in a hex editor, or would that just be kind of the same? Almost the same. Okay.
Almost the same. In hex editor, it will be a little bit prettier.
Okay, just
for
curious.
Sure. Right. Actually, with the hex editor, you can edit this data file intact. You can change some parameters, whatnot, and it will be visible if you run the web version again. And so I figured out all I need to do is to make my files, compact them into one file, and update the offsets values in the JS file. And that's all what I did. Let me show you my source code.
I like how you say that so casually. All I've got to do is just package it all up as a binary file and figure out the offsets. No big deal.
So,
Seems magical to me, but maybe I don't know what you're doing. It's how you do it.
so,
I also really appreciate your last comment about very bad coding style. Sorry, just
I
taking a
couldn't
little
help
pleasure in your
myself.
comments there.
So take a look. This is my directory for my usual Kubicorn LD file, which has all images. It has all libraries and scenes and whatnots and sounds. I deleted everything, almost everything, and left only a few files. So I have main Lua. I don't use widgets. I don't use storyboards. I don't use audios, and I use only one image, which is shade PNG, and main Lua and config Lua. I'm not sure if I should have used build settings because it's not on their sample, and I didn't include it, but I wasn't able to make it landscape. Maybe I should have included build setting as well, and it would allow me to make it landscape in the browser. But for now, for simplicity, it's on the portrait to represent exactly what Corona did. And let's look at the sample. Let me open it in my in Zero Brain. So my config Lua is actually doesn't matter. So it's only a standard one for iPhone simulation with letterbox, and that's all. That's all. Main Lua. Main Lua contains every file that I have working on, but included in one file, because this would be easier to compact them into one big data file when I have only a few Lua files by hand. Obviously, Corona does it in automatic way, I suppose, but for me it was easier if everything was already concatenated into like one file. So I have a pretty big one. It's 600 lines of code. I don't use any images besides shade Lua. This also, and I don't use any audio. So I stripped storyboard and everything else. So it runs basically in one file. Next thing I do is I go to my directory in terminal. So I type cd, drag directory to my terminal. Why doesn't it work? This way.
Please don't tell me you used cat. I've got to. I'm sorry, I interrupted. I'm guessing ahead.
Yes, it is cat.
Oh, I hate you. It's so straightforward. I mean that in the best of ways.
It is straightforward. Let me grab my last command. So here it is.
So you're basically just packaging all those files up into this cubic.data file.
Right, so consider my command. So I cat first config Lua, main Lua, and shade PNG into cubic data. I hit run, it creates the file, cubic data, and we can watch it and we can see it in the text edit. Where's my text edit?
You know, I think we can see several really important things coming out of this. First of all, we can obviously see that Corona is very close to having an HTML5 tool set for us to be able to use to be able to deploy our apps inside the browser, which is something that has been very much in demand. The second thing that we've got going on is in this initial early beta, there's obviously a little bit of concerns about security. If it's that easy to get to the information, any anybody with a limited amount of hacking skills can easily get into our materials and be able to get into it. I'm sure that before Corona releases the final, we're going to see some encryption put into our data so that it's not so
Yeah, that's
easily
definitely a
accessible.
good point, Brian. That's definitely
Well,
a
I'm not
conversation
sure
that's
if
been
I
had internally.
I'm not sure if I will how it's called um, well, decompiling Corona code isn't hard anyway because Lua our code is coming in form of bytecode, and this bytecode is shipped to clients, and this bytecode can be decoded using some special software, and I believe we can um, use Lua to make bytecodes, and it will run in Corona, and it will run in HTML versions. So it will be basically the same as in binary form in our apps on Android and iOS and in HTML. So in terms of security, it is the same, but it's not perfect, as a way. Does it answer your question?
Yeah, I think we're good. So, okay, so once you've got all that, you just uploaded everything to your web directory and you're golden, or what's the?
Yes, I upload to my web directory and my web section on my server, and it runs fine, just like that.
We can't hear you, Ed.
Wait. We're missing a step.
I'm saying that
Can you hear me now?
I can hear you. Can you hear me?
Yes, I can hear you. I keep muting my microphone because I don't want there to be bleed back when you're talking. But there's one step that you missed because I think you got distracted there. You did the cat, but we don't know how you got the byte offsets because you had to go modify your code to extract it later. So
Well,
how did you count?
Because I look at the config file, for example, and get info, and it gives me how many bytes the file is.
Okay. It gives you an accurate byte count.
Of course. I used ls.
I'm sorry, you say of course, but just for people on the Windows world.
Oh, sorry.
Okay. I know you're using a Linux derivative or Unix derivative there, so you're getting accurate byte counts. But if you're a Windows user, you don't get accurate byte counts.
You get if you click properties, there are two values. One is like a shortened version, and the other one is a long byte version.
Right.
So you do get it. But I actually used ls in terminal, and it saved me all files with all the sizes in them.
Okay, good. I just want to make sure you pointed that out. That's all.
And then I used a calculator and added them all together just by hand to calculate all the offsets for each file in my JavaScript file. Because it doesn't use like the sizes, it uses offsets in the entire file, so I have to sum them.
I just wanted to point out that, yes, Sergey is very smart, but one of the things that I really appreciate about the way he approaches these things is he approaches them there's no mystery. It's got to be straightforward. Let's just do it A, B, C, D, and look at it. Instead of, like, coming up with crazy, not like I think I do sometimes, which is come up with sort of, like, over-engineered solutions. I really appreciate this.
Thank you. So I think it is pretty straightforward.
Yeah, definitely.
They obviously didn't try to make it secret or, I don't know, locked to many developers. It's just straightforward and lays on the surface.
Well, very cool. I'll have to go out and try that. I just like the idea of being able to put everything together like that.
I suppose there will be problems with screen resolutions and some problems with performance. Also, I'm not sure if they had added support for many built-in libraries like storyboard, like widgets. I suppose they are missing in their JS file, and maybe audio is not working, but physics is working, which is good.
I'm thinking you could probably implement subdirectories if you wanted to, folders, and
Yes.
use tar or something like that? And
Well,
then
basically, you have to replace all your file names with dots. Like, when you're requiring some file in Corona, you say require directory dot file name dot, and that's all. So basically, it will be the same in this version, but you have to copy all your files into your root directory and rename them so they follow directory notation. I have written a script for doing almost this back then when Corona didn't support subdirectories in the simulator. It's somewhere in code exchange, Python file which walks through your project files and copies everything into your root directory and renames files. Yeah, you can use it.
Can't hear you, Ed.
Maybe let's.
you're making me use my OS 10 machine. You know that? You keep
What?
making me use my OS 10 machine.
We'll get you converted eventually.
I didn't hear you.
Well, I love Linux. I love Unix. It's not my primary computer, so it's not in front of me. So it's always kind of I gotta look over.
I
on
have
the left
Mac.
side.
It's not Linux. It's available to
I say Linux. I mean Unix. Mac is basically what's the derivative? What was it derived from? What
okay.
Unix?
Well, in Windows you can install Cygwin and it will be almost the same.
Okay, well, very cool. I love it. I think it's great. I love that you left the example simple and something we can follow. Not like we were talking about before. It'd be great to be able to maybe just take the project as is and just put it up there with subdirectories and resource files and all that kind of stuff. But I just like that I like that this is a clean example that we can follow without having to get too complicated. So, and is this?
I just found a link for
Yeah,
my
it's
project.
exceptional. You didn't have to do any fancy changes to the game except collapse it into one directory and get rid
Will
of
you throw
extraneous
that in the
files.
chat and I'll add it to the show notes? Yeah, please. Thank you.
Okay. It uses underscore for separation, but you have to change the underscore with the dot, and it will make almost the same effect.
Very cool. All right. Well, I think that's enough for today. That's a lot to chew on. So thank you, Sergey, for going through that. And you guys definitely go be sure to check out his new game, Hex LED. Yeah.
Follow me on Twitter.
Yeah.
Download my
now.
game, HexLED. It's free on Android and will be free on iOS in a week. And if you download it and review it, I will give you my code for Kubicorn.
Very generous. I love it. That's awesome. Yeah, I did that, and I'm still trying to dig through the code or find time to dig through the code rather. But I love it. Yeah.
Thank
and
you.
I was playing Hex LED this weekend. I'm finally getting the hang of the whole Hex playing board and everything. So that's great. But if you guys are interested, you can go check that out. There's also Sergey did a blog post on the Corona Labs blog about his experience developing the app, and also he shared some code examples and stuff that were there. So go check that out. Does anybody have anything else before we wrap this up? Announcements? Anything? Hopefully we'll get to talk about Canada at some point, Brian. I know that was quite an adventure for you as far as border crossings and all that kind of stuff. So I'm sure you have some stories to tell.
What happens at the border stays at the borders.
Except for on this show, obviously.
All right, guys. Thanks for joining us. Be back here next Monday at 12 p.m. Pacific. We'll be here talking about mobile app development using Corona SDK. And until then, have a great week and happy coding.